So we're here with this is Jeremiah, but it's not Jeremiah Pop, obviously. It's Jeremiah. What's
Ferwerda.
Ferwerda.
Mm-hmm. Yep.
And why don't you tell everyone where you're from and what you're working on here? I saw your demonstration.
I'm from Idaho, and I'm working on the thermodynamic transformer by Nikola Tesla. It's his bladeless turbine. So came down here to Albuquerque, New Mexico to give a presentation because I was invited to the conference, to this conference. At my last conference, the people, I was scheduled in before they knew that I would actually be there. And so I said, yeah. And I didn't know I would make it. I said, I probably can't make it, but if we had a truck, which we ended up having a truck, or we had a truck, but it could have broken down at any point on the journey down here.
Oh, it sounds like one of those trucks.
Yeah, and so I was like, I don't think I can make it because of the truck and because we don't have the gas money, and we kind of spent more money than we have to get down here in the first place. But somebody said, okay, you need a new truck.
Like, what does it do? What's its potential?
The Tesla turbine patent on your
It's basically everything. Yeah, it's basically everything that we've needed, that humanity has needed for the longest amount of time, because we have the technology to do what I'm doing right now, but it's extremely expensive. The turbines take advanced machines to build, and like CNC machines, advanced materials to build, and we're building, or we're using basic machinery, basic equipment to build it. So and it'll also last a lot longer than the regular turbines because it works on the principle of viscosity instead of impact, viscosity, adhesion, and friction. And so we have a system, it's called the cryophorus, where you have a boiler on one side and a condenser on the other side. And all you do is you warm one side and you cool one side. You can use the earth to cool the condenser, and you can use ambient heat or groundwater heat pump. Yep.
Yeah, we actually heard this device turning on at the conference. They turn on, sound like a air raid siren. Yeah. And then I would go out there, and one of Jeremiah's helpers was getting electrocuted from the generator. They kept on playing with it. Yeah, he seemed to enjoy it. I think he's standing right here. Or no, it was the other guy, the one with the long hair.
Yeah. Okay. Wait.
So the generator was actually putting out it looked like more than 100 watts, right?
Definitely more than 100 watts. I don't know what temperature. I wasn't there.
The frequency of the AC was pretty high too. I know
it's very high. Yeah, because our RPM is very high. We operate it. There's more power at higher RPM. So if you take 1 foot-pound of torque at 1 RPM, that same foot-pound of torque will give 20 times the power at 20 RPM.
Okay, so you need like a gear.
So, well, you normally would, but we use a generator attached directly to the turbine, and the generator, you can do this electrically without belts, pulleys, and gears, which normally kill your effects and rob power at super high RPMs because of friction. Yeah. So we don't have to worry about friction because of our electrical conversion of the energy.
That's some really good bearings, I guess.
Yeah, and the bearings, they're $70 a piece, and they're rated at 150,000 RPM. So that's the most expensive part in our system. In fact, our magnet for our generator, which is just a single magnet, diametrically magnetized, that goes on the shaft of the turbine. It's extremely simple, and it's well balanced because it's circular and it goes right on the shaft. So the generator can operate at super high RPM, and because it operates at super high RPM, or because it can operate at super high RPM, it's got a big field, and the field, you have 2 coils, 1 on each side. So once you put that magnet on the shaft, then you just put 2 coils one on each side of that magnet. And the field is so large that you don't need magnetic cores, or you don't need iron cores. Iron cores attract the magnetic field and then help you transfer that magnetic field into your coils.
You're going straight to wire.
We're going straight to wire. So it's like a axial flux generator, but instead of having 8 magnets and 16 coils, we have 1 magnet and 2 coils, and it goes straight on the shaft and it's circular. And so we can operate at super high RPMs without the need for the complexity or iron cores. Iron cores start losing more and more and more efficiency the faster they go, because and there's also ferrite cores, but they still have their downsides too. When you flip a magnetic field inside of an iron core too fast, you start to heat it up from the eddy currents formed in the iron.
Right. What's the efficiency of this turbine?
Well, the efficiency can be 99% efficiency.
Well, for the generator, for the
for the turbine.
The turbine is taking 99% of the kinetic energy stored in that steam or whatever.
Yeah.
Really?
Yeah.
I know that power plants are running around 30% efficiency, right?
Well, a lot of them. There are some out there that are very, very efficient. The problem is they're made out of super materials and they're very complex and they're hard to build. So one of my turbines, you can buy one off the shelf. It won't last as long, but it'll be very efficient. You can hook it up to the rest of my system, but it's going to cost you $20,000 for one turbine, for one small turbine. And so it's.
You're 3D printing.
I have 3D printed them in the past, but I have a basic CNC mill and a basic. I have a mini lathe from China.
We just got a CNC mill at the lab. Possibly too. That was a big to do to get that in there.
Yeah. So and you don't need the best of any of this stuff. I use a hydraulic press, a mini lathe, and a CNC mill, and I can make the entire turbine for under. It's way, way cheaper. I can make it for under $300. Of course, with R&D, I have to sell it for a lot more because we're paying for R&D, and the time that it takes to build it, I have to have employees, which I don't have.
What's the upper limits of this technology? Can we see a megawatt or a gigawatt?
Well, there's a guy out there, Frank Germano, who isn't using vacuum like we are. And he produces a megawatt at 97% efficiency with a 36-inch turbine, Tesla turbine. And this is he's kind of underground. He doesn't talk about it much. He's got a website. I had an interview with him one time.
Yeah.
Yep. And he talked all about it.
That's
But
amazing.
he works with a big company and he's not allowed to say too much. So.
You saw there's a company here, TeslaTech, who claims to be using some sort of water system making steam in order to, and they claim that it's over Unity. Maybe we could hook up your
we could, yeah.
Hook it up to that.
I want to.
Yes. Oh, let's do it.
All right.
Let's do it. We're thinking on the same level here. I like that.
Yeah, because there's a lot of over Unity stuff that people claim out there. And they can't convert it. They can't convert it because it seems to be all in the form of heat. And they can't efficiently and cheaply convert that heat into energy. If their conversion process is only 5 or 10% or 20% efficient, then they're not going to see a gain in overall efficiency because the way they're converting it shows that they're actually getting less power out than is going in. I mean, well, you never get more power out than is going in.
He claims it's happening.
Well, but there's more power coming in from another source.
He also claims
You don't get more out than in. It's coming in from somewhere.
I know. I was just.
So yeah, the laws of thermodynamics still apply, but it doesn't mean that there's not a source out there that is bringing more energy in, like
that we haven't thought about. Yeah.
Yeah.
Because he did add carbon to the water. There's graphite in there. He claims that
I need to know more about that. So I don't know anything about it yet.
Well,
I just know that what he's claiming
and coming out of the pipe, and he says there's 4,000 watts of energy.
Yeah, and imagine if we put that under vacuum, like this system, and then ran in the turbine with it.
Yeah, let's do it tonight. So
So give a quick shout.
Well,
out.
the term.
Give some search terms and like a website. Do you have any search terms where people can look
Well,
stuff up on the
we've got
website?
our Patreon, which is our biggest support right now. It's our monthly, basically our monthly income that we use for R&D. And that's iEnergy or patreon.com/iEnergy supply. That's iEnergy supply.
Oh, maybe we could get him up with his logo shirt. What's his name?
Yeah.
Ishmael.
Ishmael.
Come up here and show the shirt off. And,
Yes. This is Ishmael, who's been working the stand for the past few days. Just come right in front of Jeremiah. And here, just squish down so you can see the logo on his shirt. That is the company, Energy Supply. Oh, there.
I should just turn the camera around.
Oh, okay, whatever. Energy Supply. This is the team, and they're getting really cozy together. Check them out on Patreon, right?
Patreon. And also
Yes.
YouTube. Type in iEnergy supply on YouTube and we'll be the first thing that pops up.
Again, it's not the same without the demonstration of what you got downstairs to show us. I know you're going to go do that next. Can I join you and film that, and I'll post it on the channel later for people to watch?
Absolutely.
All right.
Yep.
Yeah. So I'm going to go get a film of a demonstration of his Tesla turbine and his whole setup.
And that's in 20 minutes, I think.
20 minutes.
Okay. You're gonna run down there in 20 minutes.
Yeah, I'll run down there. I'll run down there in 20 minutes. If you have anything else to say, I mean,
Are you done?
You were
I
talking.
think I'm done. If there's any other, do you guys have any questions for me?
Is there any questions from APEC?
Or the live stream. I don't see too much of the live stream. I'm looking at the live chat right now.
We're talking Tesla turbines.
He said if it works, you're done. The CIA will get you.
Oh, they might already be here. Who knows?
Yeah.
There's some really weird people.
I haven't met any really weird people yet. I did it at my last conference.
Free and open source.
Like, what are you doing?
Free and open source. No patents. I like it.
Yeah, free and open source. YouTube channel. Nikola Tesla's technology, just fully applied.
Yep.
And
That's
not-
the way it should be. That's the way it should be. I mean, you should get the patents for the nuts and bolts, like the best bearing that you use over there, the $70 bearing, that's your IP, but the general idea doesn't belong to anybody. It's been around since Tesla,
Yeah.
since Tesla's age.
Yeah.
I think we have a question here.
Yes. Volume 2 of the TeslaTech series. Good old Steve should be reprinting this book. I don't know if you can see it because they have a virtual background, but it's the classic boundary layer breakthrough, the bladeless Tesla turbine, compiled by Jeff Hayes. So I hope Steve will reprint it.
Oh, I
He
think
was supposed to present. Jeff Hayes was supposed to present, but he didn't.
Excellent. Well, this is actually a very valuable book to have for. that
Yeah,
topic.
Jeff Hayes' book. Yeah,
Yeah.
it's extremely
Just
important.
showing up.
Jeff Hayes wasn't able to make it to the conference, unfortunately.
Yeah.
It's actually been a very light year for TeslaTech.
Yeah.
And but the people that are here are the highest caliber. You're just getting it's just more concentrated minds. That's all we got with it.
That's
You know, it wasn't the ones that didn't make it weren't supposed to be here. The ones that are here are here.
Yeah.
And that's what's important. And
That's important.
thank you very much, Jeremiah. That was
Thank
it was
you.
amazing. I really like that contraption. You turn it on, sounds like an air raid siren, and
Yeah.
we see all the Einstein,
And,
the Edison lamps
And you won't
lighting up.
hear it when it's. We had an issue with our magnet being off center because the magnet that I got for it, the company that you order the magnets from, you have to specifically ask for a symmetrical magnet. And the symmetrical magnet that I specifically asked for was broken when I pressed it onto the new shaft. So we got a bunch more magnets on the way, but it was imbalanced to begin with. So the magnet was off center. I had to slide some Lexan rings around the magnet and balance it at high speeds, but it wasn't perfect still. And that's where the noise is coming from.
Oh,
So
okay.
the noise will be gone. Ideally, it'll be almost silent. You could whisper and have a conversation right next to it.
That's really cool.
So yeah, when you have something really loud, you're losing efficiency. So if this was a regular turbine, you'd have to have earmuffs on. You couldn't, or your ears would be damaged really fast. Like it would be so loud. And that's of course because there's efficiency losses and your turbine's being destroyed.
And those are impact.
Yeah,
connection.
impact, primarily impact. Also, if it was imbalanced, like ours is right now, then you would hear loud noises from the imbalance. But that's just a simple magnet issue. And
this is basically, you're dealing with friction instead of impact.
yeah, friction and viscosity and adhesion. So if you take a piece of glass, or you could just take your hand, drop some water on your hand, it sticks to your hand and it drains down, and the force that's adhesion that's causing it to adhere to your hand is viscosity and friction. And that's the force that moves the blades of the turbine. And a regular turbine uses impact. So it's an actual particle flying at high speeds into essentially a wall.
In a normal turbine, that impact force causing supercavitation will actually damage the turbine.
Yeah.
wear
And
it
that's
out
one
over
issue
time.
that the Tesla turbine doesn't have. It doesn't have issues with cavitation.
Really?
Yeah.
Interesting.
So you can have much higher velocity of fluid and you can run at much higher speeds.
So they're not seeing that bottom graphic on your shirt. The turbine from a side view actually has these, like slots. It's like there's no. It's not.
If
like
you
a water
just,
wheel
I guess we should just say, look up patent 1061206.
Yep.
It's and then read the Tesla turbine patent.
From May 6th, 1913.
Yeah.
Yep. And if you read that patent, you get the gist of what this Tesla turbine is all about. And one of Tesla's many great inventions.
Yep.
Thank you very much, Jeremiah.
Yeah.
Okay.
Thank you.